So good morning everyone, my name is Alex Torres and I'm going to talk about a little bit what my paper was. It's a bibliographical review about polymer nanocomposites. So the title of the paper was Polymer Nanocomposites, a deep review into world's material. But first of all, I want to talk about a little bit about nanotechnology. So what is nanotechnology? Nanotechnology involves the possibility to see and to manipulate individual atoms and molecules. As we know, atoms are in everything on Earth. For example, in the food that we eat, in the clothes we wear, in the buildings that we are living in, and also in our own body. So the first concepts of nanotechnology were first introduced by the renowned physicist Richard Feynman. With this talk, there is a plenty of robot at the bottom. But it was in 1959, but the name of nanotechnology was firstly introduced by Norio Tinaguchi in 1974. So, nanotechnology is the manipulation of molecules in a range of 1 to 100 nanometers. So, these definitions reflect the fact of the quantum mechanicals that are important for these quantum scale levels. So, we also know that it's really difficult to understand how small is nanotechnology. Because, for example, I'm going to make some comparations. 1 inch is 25 millions of nanometers. And also, only a sheet of a newspaper is 100,000 nanometers. So we can also know that nanotechnology can be used across any field of science, like biology, chemistry, physics, engineering. Here are some applications for nanotechnology, bioengineering, nanodevices, energy, defense and security, materials. There is a whole world of this. And we also know that recently we have reached the limit of optimizing composites in the optimizing properties of composites in a micrometer scale, because achieving these properties have compromises. For example, stiffness is traded by tautness, and tautness is achieved by the cost of optical clarity. So here's where nanocomposites take the steps. What is a nanocomposite? It's a solid material formed by multiple phases where at least one of its constituent phase is less than 100 nanometers. So, as long as we're talking about this topic, our guide will be the Mother Nature, because of their nanocomposite structures as bonds. For example, we know that a bond is a combination of ceramic tablets and organic beans. There are three types of nanocomposite matrix, but we are going to focus only on the polymeric composites because of their applications. Yeah. The other ones are ceramic matrix composites. These are the group where the main value of its volume is occupied by ceramic. These ceramics could be oxides, chemical compounds as oxides, as nitrites, etc. The other one is the metal composite matrix. These ones are also known as reinforced metal composites, because it's the same as the big one, but what has changed are the reinforced fillers that are inside of the metals. So here's polymeric nanocomposites. What is a polymeric nanocomposite? It's a polymer or copolymer that is having nanofibers or nanoparticles dispersing in the matrix polymeric matrix. These fillers can be they are in different shapes. For example, spheroids, nanofibers, and also nanoparticles. So I'm going to talk about these reinforced phases, are the nanofillers. Here we can see. The first one that I told you is a nanofiber. This one are in, its diameter is less than 100 nanometers. The most common types are the carbon nanotubes. The second one are the fiber fillers that are three-dimensional particles. With his range is less than 100 nanometers in its larger dimensions. And the third one are these big ones from here are the plate-like fillers. The most common of these are the layered silicates. What's special from this is his thickness is only, the most typical is only 1 nanometer thick, but his aspect ratio is about 25 nanometers or above. So the nanoparticle filler, its importance are related on its size and how it's distributed, because the polymeric nanocomposite will be affected by the quantity of these nanoparticles. The other ones are the 1D nanofillers, carbon nanotubes. They are really unique because they have really big problems when they are in contact with the polymeric matrix because of its high surface, its aspect ratio, and several critical factors need to be addressed in these kind of nanofillers. Uniform dispersion of the carbon nanotubes within the polymeric matrix, the alignment of the carbon nanotubes in the nanocomposites, and the good interfacial bonding between the carbon nanotubes and the polymer matrix. The third one is the three-dimensional nanofillers. They are the plate-like layered nanofillers. This one, the most common are layered silicates, in case, for example, non-modelinite nanosilicates. The good about these fillers, when they are in contact with the polymer matrix, the properties can achieve enhancement such as UV resistance, gas permeability, increased stiffness and strength, and also a superior flame resistance. Yeah. So these are also the advantage in their properties. I'm going to describe some of them afterwards. These are flammability, resistance, thermal, electrical, optical properties, biodegradability, permeability, thoughtness, strength, stiffness, etc. Here we have one example of the properties. In these graphics, we can control the heat release. When we add the nanofillers, the heat release starts to low and start to stabilize. So increasing flammability resistance has been noted as an important property enhancement in nanofillers as fibers or plated, because when you modify them, you can modify also the polymer matrix. So there are also optical properties. There is a really interest of developing transparent nanocomposites. But when you want to create this transparency, when you want to achieve transparency, you need two things. That the nanoparticle should be as small as it could be, and its index refraction should remain similar as the index refraction of the matrix. So there are also thermal properties. The inclusion of carbon nanotubes can be used to improve the thermal conductivity. These carbon nanotubes create a percolation network. Percolation network is like a filtration network that allows the nanocomposite to conduct the heat. But what is better here is that the conduction will be 3.5 as the conduction the heat conductivity of the pure polymer. Here are some another nanofillers. We can create infinity combinations. Exfoliated nanoclays, for example, when we use graphene, the property enhancement could be charge transport, electrical conductivity, and the play application could be electrical, electronics, and so on. There are some applications also in the use of polymeric nanocomposites. The first one could be in biomedical. Polymeric nanocomposites have been proposed to the application of drug delivery release systems. When a nanoparticle is introduced in these systems, it improves impediment that the drug could be, so the drug could be released more slowly and could be more controllable. In the case of fuel cells, we have known that polymeric nanocomposites, or the polymer have involved in the proton exchange membranes. So using this, the use of these nanocomposites, using these nanocomposites, there's a lot of publications about they can improve the mechanical properties and also the proton conductivity. There are also the electrical and electronics uses. For example, we know that electronic devices have already reached the nano range because we are always trying to have more powerful and more little devices, for example, cell phones. And commercial applications, here we can have a lot of different applications with different combinations of polymer matrix, nanoparticles, and companies that are already using it. For example, we have the epoxy, that is a type of foam that when you use carbon nanotubes, the strength of stiffness it increases, it uses in hockey sticks. So the conclusions is that this use of this nanocomposite, polymeric nanocomposites will increase the development of the technology, because when you use a polymeric nanocomposite, the promise relies in the multifunctionality, the infinity possibilities of realizing new combination of properties of new materials. This can be applied in different areas, as I have described in this presentation. Thank you.